Today, we're cutting this 30-pound block of aluminum into a finished part that weighs just 2 pounds. The challenge isn't just removing material fast, it's making sure the part doesn't bow under stress. Here's how we prevent that. We start by loading our dovetail prep material onto our 5th axis vices with an integrated hard stop. The stability of this fixture will allow us to take aggressive cuts. The first tool on this operation is from Iskar. It's a 32mm shoulder mill. As you can see, this tool removes material really fast and creates a solid chip that's easy to manage. Right now, I'm running at about 8,000 RPMs at 150 inches a minute. It's taking a 3/4 inch step over with a 0.35 step down. Perfect for ripping through material, and now we can see our part taking shape. The only drawback of this shell mill is that it can't reach tight corners. That's when we switch to a 1/2 inch chipbreaker end mill. We run this at 12,000 RPMs at 180 inches a minute. Here, we're using a strategy called rest machining, which basically means the tool only cuts where stock is left over. That way, we keep our tool engaged, which helps us reduce our cycle time. Once the bulk of the stock is gone, it's time to think about the surface quality and tool life. That's where the bullnose end mill comes in and starts the semi-finishing. We slow things down at 50 inches a minute and start cleaning up the 3D surfaces. It might seem excessive, but semi-finishing is extremely important. It smooths out the part and takes a load off our finishing tool. That means a better surface finish and a longer life for the ball end mill. Next, we bring in an 1/8 inch ball end mill for finishing. We're running at 12,000 RPMs at 80 inches a minute. This tool smooths out the tiny cusp left behind by the previous tool path. It'll bring the part right into its final geometry with a clean, smooth surface finish. To wrap up, we drill a couple of holes and deburr with a tapered ball end mill. We utilize all axes on our DMC 75 to reach every edge and corner. Now that the first op is done, it's time for the second op. We move the part over to the Haas VF-2. The biggest challenge here isn't cutting, it's fixturing. The part's too big for a standard 6-inch vise, and with thin walls, clamping pressure can easily cause it to bow. To solve that, we designed a custom fixture with a negative geometry that matches the surfaces we finished in Op 1. That way, the part sits perfectly flat and supported with no room for distortion. We start roughing with the same helical end mill from Op 1 at 12,000 RPMs. To keep the toolpath aggressive, we program around the toe clamps holding the part. Once the roughing is done, we pull the clamps off and swap them in for bolts. Then it removes the material from the areas that were blocked before. From there, the process mirrors Op 1, semi-finishing, finishing, and deburring. And finally, we engrave the logo with a ball end mill, leaving the part complete with a clean, finished detail. If you like content like this, subscribe to our channel.